Hi everybody, this is Duke with a video on this mission challenge assignment, corridor scan. We're actually going to change this assignment a little bit from how I've done it in the past. We're going to use QGroundControl for this. Give you a little more experience with QGroundControl. So I'm going to go ahead and jump into QGroundControl and show you what I'm talking about here, and then we'll be able to use this video to do the assignment. So let's say we're at our flight location and you have a vehicle that is capable of taking photos. Of course, that's simulated. Our copters can't take photos without a camera, but let's imagine they could. And we want to do a scan of a corridor, or not just a large field, but a specific kind of route, for example. Okay, so let's say we want to do a corridor scan here of the gravel kind of road, and then out into this break between the fields a little bit here. We want to scan that area and get some good imagery of that path. So how would you do that in QGroundControl? And we can use some of the advanced tools here that help us kind of auto plan missions. Much nicer user interface. A lot of this user interface is much better than a mission planner in my opinion, though the same functionality I believe is largely there in both places. We're going to go ahead and let's say we're on our main page here. We're going to go to the plan page. Okay. And we're going to make sure our vehicle info is correct. Ardupilot, multi-rotor. Okay. Initial waypoint altitude. Now this would be more important if we had a specific camera type we were using, based on how good the camera is or what the sensors we're using. We might need to fly higher or lower to the ground. For the purposes of this, we're just going to leave it at the default. Okay, but that's all set there. So we can go over to the left-hand side now, and we can save file, and we can choose corridor scan. And it's going to give us some kind of red things over here saying, hey, we need to set this up still. So let's move T to the takeoff to the climb out location. So kind of where we're going to take off from, right? So I'm going to say over here again. Okay. I'm going to say done. Great. There's a specified altitude. It should be able to take off from that spot, climb it to 164 feet without any obstacles. So that's great. Then we need to perform the actual corridor scan. You can see it's highlighted in red here still. So click on that, and then it says use the polyline tools up here to create the polyline which defines the corridor. And so you can do basic, and you can kind of just drag things around and add things in and, make the corridor that way. But let's go ahead and do something different. Let's do corridor scan. Start over, yes. Okay, move this over here. Done. Corridor scan itself, let's use the trace. Okay, so we just need to add vertices, or basically the path. Okay, we want the vehicle to fly at. So let's say here. And we just need to go out to, let's say, the, oops, didn't mean to do that one. Let's move that over here. We'll say about that far in the field is good. Okay, so we have a corridor path there to almost the edge of the field. We can say go to the edge of the field. Okay, in this simulated example. That would be pretty hard to see the vehicle if you're standing over here that far away, so I wouldn't recommend doing this actual flight, but you get the idea. Okay, so once we're done tracing, oops, supposed to click that button before I'm done tracing. Let's just put that right back in there. Okay, we'll say done tracing. It's going to then generate the actual flight path for us here in the corridor scan box on the right hand side. Okay, you notice you can also load a KML file into this to use for the corridor. That would be really helpful if you had a KML file you had maybe walked or driven the corridor and you had some kind of app or something where you're loading or logging your GPS points as you go, and you create a KML from that. Load the KML in here and it can auto generate from that path. Okay, but for now we just traced our path and that's fine. Over here on the corridor scan pop-up, we have a lot of valuable values and variables and things like that. Okay, front lap and side lap has to do with your camera photos. Okay, and 70/70 is pretty standard, I believe, although you could even go more than that. That just means that each photo you take will overlap the next photo along the flight path by 70%, both front to back and side to side. There's a lot of overlaps required for a lot of the processing software to then stitch the images together and coordinate them and everything. Okay, we can select ground or an altitude for the corridor scan in terms of altitude above the ground, or we can select a ground resolution in the sense of how what the resolution we want out of this flight would be. Again, this would be dependent on the camera quite a bit, but you can set it either way in terms of what you're looking for. Okay. width of the corridor and turnaround distance of the corridor, so you can adjust those. Let's take a look at that real quick. So if I say the width of the corridor is, instead of 120 feet, let's say it's 300 feet. Okay, you can see the jumps out like that to cover the area that I'm requesting. 300 feet, width. This is the center line of the corridor that we drew with those vertices earlier. Turnaround distance, we should see that over here somewhere. I'm going to extend this out a little bit so it makes more sense. Okay, turnaround distance, let's change that. Instead of 32 feet, let's say we want it to be 80 feet. We got plenty of space to turn around at the end of each pass, we can say. So you can see that extended out there. If I made it much smaller, then we would have a shorter turnaround distance here. Okay. And if there's multiple passes, it would affect the turnaround distance over here as well as over here. Okay. Images, you want to take pictures when it's turning around or not, yes or no. And then rotate the entry point. So that means if I'm starting from over here, it's going to kind of enter right here is what it's doing right now. If I hit rotate entry point, now it's going to enter right here on this other side. If I hit it again, it's going to rotate over on this side of the mission, even, which doesn't really make sense if I'm launching from over here. But in certain other applications, it could be beneficial to put that in any given position along the corridor, if that makes sense. Okay. These are the corridor scan kind of flight settings. We have camera settings here. We can just say we're using a GoPro, or you could say, oh, I'm going to use a red edge, and it changes the flight path there because it knows details about this camera that would be required to get the coverage you want. So if you do have an actual camera, then you want to make sure you set it appropriately so you get the right mission plan for your camera type. But in our case, it doesn't really matter. We don't actually have a camera in this case. You see these variables down here will change. Let's go back to the GoPro. Okay, these numbers are all changing when I change between cameras. Okay, and that's why the flight paths become less or more, etc., etc. Sony camera. Okay, let's say 6000, 35 millimeter. Look at that. So it changes the flight path, how many passes it does based on the lens and the sensor and everything of that nature on the camera. Okay. For the relative to launch, you can just leave that alone because we're doing altitudes relative to launch. If you wanted to change that, you could change it to something else above terrain. Okay. And then the settings here, presets, we don't have a preset, but you could use that to apply presets to the mission. Okay. I'm going to go ahead and set this back to the GoPro just because we don't want to make this a really long mission to fly. Okay. And so you could have your mission set like this. You would then be able to save that to your computer or upload or download it from the vehicle in order to actually fly it. So I hope that helps. You can also do other types of plans in here. I have you guys doing a corridor scan, but you can do a survey. Do a survey, kind of similar takeoff point there. Let's say it's there. Survey, we're going to do a circular path, for example, right here. That works great. And you have a lot of the same things here. Okay, altitude, trigger distance for the camera, spacing. All these things here are available for you to tweak the survey plan, change the angle at which the survey happens. Okay, and then you can go ahead and upload it or save it to your vehicle, or upload it, etc., etc. So I hope that helps a little bit. On this specific assignment, I want you to do a corridor scan, but you can play around with the tools and see what else you can do there inside the planning software. All right, hopefully that helps. When you finish the flight, you'll upload again your files, basically. In this case, I want you to have a T-log file, so a telemetry log. You should have a telemetry while you're flying autonomous mission, so you know what's going on. You have a data flash log, and I have another video down here that talks about how to convert a data flash log file into a .kmz file that you can view in Google Earth, which is really cool. So you want to submit the KMZ file and then a screenshot of the data flash log there. Okay, and this video will go over how to convert, again, a data flash log into a KMZ file there, which is pretty cool. All right, that should take care of it. Thanks.